run it with GPUs. And so that's the instant ROI that you get by acceleration. Now, beyond that, the generative AI conversation is in the first wave of Gen AI, which is where the infrastructure players like ourselves and all the cloud service providers put the infrastructure in the cloud so that developers could use these machines to train the models or fine-tune the models, guardrail the models, so on and so forth. And the return on that is fantastic because the demand is so great that for every dollar that they spend with us translates to $5 worth of rentals. And that's happening, all over the world, and everything is all sold out. And so the demand for this is just incredible. Some of the applications that we already know about, of course, the famous ones, OpenAI's ChatGPT or GitHub Copilot or code generators that we use in our company, the productivity gains are just incredible. There's not one software engineer in our company today who don't use code generators, either the ones that we build ourselves for CUDA or USD, which is another language that we use in the company, or Verilog, or C and C++ and code generation. And so I think the days of every line of code being written by software engineers, those are completely over. And the idea that every one of our software engineers would essentially have companion digital engineers working with them 24/7, that's the future. And so, the way I look at NVIDIA, we have 32,000 employees, but those 32,000 employees are surrounded by, hopefully 100x more digital engineers.
Sure.
Yeah.
Sure. Lots of industries embracing this.
Yeah.
What use cases, industries are you most excited about?
Well, in our company, we use it for computer graphics. We can't do computer graphics anymore without artificial intelligence. We compute one pixel, we infer the other 32. It's incredible. And so we hallucinate, if you will, the other 32. And it looks temporally stable, it looks photorealistic, and the image quality is incredible, the performance is incredible. The amount of energy we save, computing one pixel takes a lot of energy, that's computation. Inferencing the other 32 takes very little energy, and you can do it incredibly fast. So one of the takeaways there is AI isn't just about training the model. Of course, that's just the first step. It's about using the model. And so when you use the model, you save enormous amounts of energy, you save enormous amount of time, processing time. So we use it for computer graphics. If not for AI, we wouldn't be able to serve the autonomous vehicle industry. Mm-hmm. If not for AI, the work that we're doing in robotics, digital biology, just about every tech bio company that I meet these days are built on top of NVIDIA. And so they're using it for data processing or generating proteins or for new...
That seems like a super exciting space.
It's incredible. Yeah. Small molecule generation, virtual screening. Just that whole space is going to get reinvented for the very first time with computer-aided drug discovery because of artificial intelligence. Mm-hmm. And so incredible work being done there.
Yeah. Talk about competition. Talk about your competitive moat. There's certainly group of public and private companies looking to disrupt your leadership position. How do you think about your competitive moat?
Well, first of all, I think there are several things that are very different about us. The first thing is to remember that AI is not about a chip. AI is about an infrastructure. Today's computing is not build a chip and people come buy your chips, put it into a computer. That's really kind of 1990s. The way that computers are built today, if you look at our new Blackwell system, we designed 7 different types of chips to create the system. Blackwell is one of them. So the amazing thing is when you want to build this AI computer, people say words like supercluster, infrastructure, supercomputer, for good reasons. Because it's not a chip, it's not a computer per se. And so we're building entire data centers. By building the entire data center, if you just ever look at one of these superclusters, imagine the software that has to go into it to run it. All the software that's inside that computer is completely bespoke. Somebody has to go write that. So the person who designs the chip and the company that designs that supercomputer, that supercluster, and all the software that goes into it, it makes sense that it's the same company. because it'll be more optimized, it'll be more performant, more energy efficient, more cost effective. And so that's the first thing. The second thing is AI is about algorithms, and we're really, really good at understanding what is the algorithm, what's the implication to the computing stack underneath, and how do I distribute this computation across millions of processors, run it for days on end, with the computer being as resilient as possible, achieving great energy efficiency, getting the job done as fast as possible, so on and so forth. And so we're really, really good at that. And then lastly, in the end, AI is computing. AI is software running on computers. And we know that the most important thing for computers is install base, having the same architecture across every cloud, across on-prem to cloud, and having the same architecture available, whether you're building it in the cloud in your own supercomputer or trying to run it in your car or some robot or some PC, that having that same identical architecture that runs all the same software is a big deal.
Yeah.
It's called install base. And so the discipline that we've had for the last 30 years has really led to today, and is the reason why the most obvious architecture to use if you were to start a company is to use NVIDIA's architecture, because we're in every cloud, we're anywhere you like to buy it, and whatever computer you pick up, so long as it says NVIDIA inside, you can take the software and run it.
Yeah, you're innovating at an incredibly fast pace. I wanted you to talk a little bit more about Blackwell. 4 times faster on training, 30 times faster inference than its predecessor, Hopper. It just seems like you're innovating at such a quick pace. Can you keep up this rapid pace of innovation? And when you think about your partners, how do your partners keep up with the pace of innovation you're delivering?
The pace of innovation, our basic methodology is to take, because remember, we're building an infrastructure, there's seven different chips. Each chip's rhythm is probably at best 2 years. At best 2 years. We could give it a midlife kicker every year, but architecturally, if you're coming up with a new architecture every 2 years, you're running at the speed of light. Okay, you're running insanely fast. Now we have 7 different chips, and they all contribute to the performance. And so we could innovate and bring a new AI cluster, a supercluster, to the market every single year that's better than the last generation, because we have so many different pieces to work around. And so when Blackwell is 3 times the performance, for somebody who has a given amount of power, say 1 gigawatt, that's 3 times more revenues. That performance translates to throughput. That throughput translates to revenues. And so for somebody who has a gigawatt of power to use, you get 3 times the revenues. There's no way you can give somebody a cost reduction or discount on chips to make up for 3 times the revenues. And so the ability for us to deliver that much more performance through the integration of all these different parts and optimizing across the whole stack and optimizing across the whole cluster, we can now deliver better and better value at much higher rates. The opposite of that is equally true. For any amount of money you want to spend, so for ISO power, you get 3 times the revenues. For ISO spend, you get 3 times the performance, which is another way of saying cost reduction. And so we have the best perf per watt, which is your revenues. We have the best perf per TCO, which means your gross margins. And so if we keep pushing this out to the marketplace, customers get to benefit from that, not once every 2 years, and it's architecturally compatible. And so the software you developed yesterday will run tomorrow. The software you developed today will run across your entire installed base, so we could run incredibly fast. If every single architecture was different, then you can't do this. It takes a year just to cobble together a system.
Yeah.
Because we built everything together, the day we ship it to you, and it's pretty famous, somebody tweeted out that in 19 days after we shipped the systems to them, they had a supercluster up and running. 19 days. You can't do that if you were cobbling together all these different chips and writing the software. You'll be lucky if you could do it in a year. Yeah. So I think our ability to transfer our innovation pace to customers, getting more revenues, getting better gross margins, that's a fantastic thing.
The majority of your supply chain partners operate out of Asia, particularly Taiwan.
Yeah.
Given what's going on geopolitically, how are you thinking about that as you look forward?
Yeah, the Asia supply chain, as you know, is really, really sprawling and interconnected. People think that when we say GPUs, because a long time ago, when I announced a new chip, a new generation of chips, I would hold up the chip. And so that was a new GPU. NVIDIA's new GPUs are 35,000 parts, weighs 80 pounds, consumes 10,000 amps. When you rack it up, it weighs 3,000 pounds. And so these GPUs are so complex. It's built like electric car, components like an electric car. And so the ecosystem is really diverse and really interconnected in Asia. We try to design diversity and redundancy into every aspect wherever we can. And then the last part of it is to have enough intellectual property in our company. In the event that we have to shift from one fab to another, we have the ability to do it. Maybe the process technology is not as great. Mm-hmm. Maybe we won't be able to get the same level of performance or cost, but we will be able to provide the supply. And so I think in the event anything were to happen, we should be able to pick up and fab it somewhere else.
Yeah.
We're fabbing it at TSMC because it's the world's best. Yeah. And it's the world's best not by a small margin. It's the world's best by incredible margin. And so not only just the long history of working with them, the great chemistry, their agility, the fact that they could scale. Remember NVIDIA last year's revenue had a major hockey stick. That major hockey stick wouldn't have been possible if not for the supply chain responding.
Yeah.
And so the agility of that supply chain, including TSMC, is incredible. And in just less than a year, we've scaled up CoWoS capacity tremendously. And we're going to have to scale it up even more next year and scale up even more the year after that. But nonetheless, the agility and their capability to respond to our needs is just incredible. And so we use them because they're great. But if necessary, of course, we can always bring up others.
Yeah. Company's incredibly well positioned. A lot of great stuff we've talked about. What do you worry about?
Our company works with every AI company in the world today. We're working with every single data center in the world today. I don't know one data center, one cloud service provider, one computer maker we're not working with. And so what comes with that is an enormous responsibility, and we have a lot of people on our shoulders, and everybody's counting on us, and demand is so great that delivery of our components and our technology and our infrastructure and software is really emotional for people. Mm-hmm. Because it directly affects their revenues, it directly affects their competitiveness. And so we probably have more emotional customers today and deservedly so. And if we could fulfill everybody's needs, then the emotion would go away. But it's very emotional. It's really tense. We've got a lot of responsibility on our shoulder, and we're trying to do the best we can. And here we are ramping Blackwell, and it's in full production. We'll ship in Q4 and start scaling in Q4 and into next year. And the demand on it is so great. And everybody wants to be first. Yeah. And everybody wants to be most. And everybody wants to be. And so the intensity is really, really quite extraordinary. Yeah. And so I think it's fun to be inventing the next computer era. It's fun to see all these amazing applications being created. Yeah. It's incredible to see robots walking around. It's incredible to have these digital agents coming together as a team, solving problems in your computer. It's amazing to see the AIs that we're using to design the chips that will run our AIs. All of that stuff is incredible to see. The part of it that is just really intense is just the world on our shoulders, and so sure. So less sleep is fine, and we're gonna 3 solid hours. That's all we need.
Well, good for you. I need more than that. I could spend another half hour. Unfortunately, we've got to stop. Jensen, thank you very much. Thank you for being here and sharing with us today.